Welcome, Math 107 students, to the preview exercises for Lesson 3, Intro to Graphs and Graphing Utilities. Let's take a look at the first preview exercise. We use the coordinate plane to help us visualize a relationship between two variables. Often we call these variables x and y. And a graph is the set of all points called x comma y that satisfy a given equation. In this case, the equation we're going to be looking at is y equals 4 minus x squared. So your first job here is to graph the following equation by just plotting some points. And it doesn't matter what you pick for x, but what's important is that you pick some negative values for x. Usually we pick 0 for x and then some positive values, just so you can have enough points plotted so you can see the shape of the graph. Now, depending on what equation you're graphing, sometimes you need more points than other times. But in this case, I figured if I gave you these 7 values for x, we'd have a pretty good idea of what the shape of this graph is. Now, I'm sure some of you, because of your previous algebra background, already have a good idea of what type of picture this graph is going to have, or the shape of the graph. So notice I've done this very first value for you, x equals 0. And to find the corresponding y value, all you do is put the 0 in for x and follow this formula right here. So when I put 0 in for x and square it, I get 4 take away 0, and I end up with 4. That becomes my y value. So the very first point I'm going to graph here is 0, 4, which sits right there. Remember, we also call the points that lie on the x-axis the on the y-axis the y-intercept. So this is our y-intercept. So now you take a few minutes and fill in the rest of this table, and we'll come back and graph the remaining 6 points. Okay, we filled in the table, and we have the following points. -3, -5, which is right here. -3, -5. We have -2, 0, which has a special name called x-intercept. We have the point -1, 3, just right there. And now we hit 0, 4, and notice that at 1, we're starting to fall back down again. From the height of 4 here, we're now at 3. And at 2, we're sitting on the x-axis again. So that's another x-intercept. We have 2 x-intercepts here. And at 3, we're back down at -5. So if you were to do a quick sketch of this graph, you would connect these 7 dots with a curve, and your graph would look something like that. Well, I got a little off there at the end. Okay. So, yeah, and I just wanted to point out a couple of things, or one thing in particular. Notice when I put in the -3 and squared it, I put it in parentheses. But when 3 was positive, I didn't have to put it in parentheses. And it's very important that whenever the base of your exponent is negative, it must be in parentheses, because what this means is -3 times -3, which is 9. -3 squared is not the same thing as this. And I know it's enough to drive you insane. They look the same, but they're not. This says -1 times 3 squared, or the opposite of 3 squared. Okay, so this actually says -1 times 3, which is -9. So anytime you're squaring a negative number, please remember to put the parentheses around the base of your number. Again, -3 is called the base, and 2 is called your exponent. All right, just a little technicality here. So what name do we associate with the shape of this graph? Parabola. What is the greatest and maximum value of y? So if we look at our different values of y, we have a -5 for y, a 0, a 3, and a 4. And as you can see, this parabola reaches its highest value at the point y equals 4. It's the maximum value. The next question asks us a little different question. It says, what values of x are solutions to this equation? So what values of x? So in other words, our equation looks like this. And now I want to know, if I replace y with 0, what values of x would solve this equation? Well, generally, we do this equation with algebra, but we have the answers right here at our x, by looking at our x-intercepts, because our x-intercepts have 0 for our y value. So positive and -2 are the two solutions to this equation. So the two solutions, or the two values of x that make y equals 0, are x equals -2 and x equals +2. Now, our book and our author and our homework in my math lab, whenever you have more than one solution to an equation, then they call it a set. Even when you have one solution, they call it a set. So remember, often you'll be asked to put it inside of those little curly braces as the solution set. That's for your homework. It's fine with me if you write it like that. You could also write it like this, +or -2. It's okay with me. Okay, so often when we have quizzes and exams in this class, I'll ask you some true-false questions. So I'm trying to introduce you to some true-false questions so that you can get used to thinking about them and how to answer them. So this is typically the directions you'll see for your true-false questions. Determine whether the following statement is true or false. If it's false, change the sentence so that it's true. So let's take a look at it first. It says, if the points x, y, and the opposite of x, comma, y lie on the graph of y equals 4 minus x squared. It says the points x, y, and the opposite of x, y lie on the graph of y equals 4 minus x squared. Well, you might say at first, what are you talking about? I've been looking at, numbers and putting them in. So now we're asking you to generalize. What do you notice about the values for these points? So notice here we had -1, 3 and 1, 3. We had -2, 0 and 2, 0. We had -3, -5 and 3, -5. So what this is saying here is, did our y values stay exactly the same if we changed our x value to its opposite? So let's see. When I was 3 and my x value was the opposite, -3, did I stay at the same exact height below the x-axis? They were both 5 units below the x-axis. How about -1 and 1? Those x values are opposite. Yep, I'm at the same height. Y equals 3. Y equals -5. And the same is true for -2 and 2. Our y value is 0. This is true for any x value on this graph and its opposite. So this is a true statement. Okay. Now, I did not assign true-false questions which appear at the end of every single section in your textbook. So it's a really good idea is for you to check the true-false questions in your textbook. And there's usually like 3 or 4 of them, 3 to 4 questions. And this will just help you to prepare for something that's not just performing a skill, but it helps you with the conceptual part of the course. That's the preview exercises for lesson number 3. Please let me know if you have any questions.